Hello class, welcome to this tutorial. In this video we are going to see how to solve logarithmic functions. Here we will solve the three questions. Before starting, let's see the guidelines to solve the logarithmic functions as a base. The first thing you need to do before solving the logarithmic functions is that finding the domain of each term. For each logarithmic expressions, we need to find their respective domains. Remember that the logarithm of x to the base a, if a greater than 0, have a domain of x greater than 0. Because if you change these logarithmic functions in exponential form, it will be logarithm of of x to base a equal to y. If you say that, it will be a the power of y equal to x. So this x cannot be negative number because there is no value of y that can give a value of negative number. So the domain of these logarithmic functions will be positive number. That is what means a domain. After solving the domain of each term, we need to find the intersection of each domain, because the solution that we got have to fulfill all the domains for all numbers. After finding their intersections, we can find or we can solve the value of x by any method you want. Basically here we will use one of the two methods. The first one is changing the logarithmic functions to exponential form, and then after changing, for example, if a the power of x equal to a the power of y, this can be satisfied if and only if x is equal to y. This is the first thing. If you have a form of a simplified logarithmic functions like logarithm of x to the base a equal to logarithm of y to the base a, this can be satisfied again if and only if x and y are equal. So we will use one of just two terms. After solving the value of x from one of the two methods, we need to check if the solution is in the domain or not. So the last we have to do is selecting the solutions that are valid or those which are in the domain. These are the basic guidelines to solve one logarithmic functions. Don't forget those four basic things. So let's gonna start solving these questions. The first question is the logarithm of x to the base 5 plus logarithm of x plus 1 to base of 5 equal to logarithm of 2 the base 5. So we can simplify this left hand side to one expressions, but before that the first thing we need to do is finding the domain of each term. Let's do that. So the domain of the first expression, logarithm of x to the base 5, would be this x should be greater than 0, as we know. For the second, this x plus 1 should be greater than 0. That means x must be greater than negative 1. The right hand side is valid because this logarithm of 2 to the base 5 have its own value, so it can be all real number. After that, we need to find the intersections of this domain of each term. So that means the intersection of x greater than 0 and x greater than negative 1 means the value of x that is solved should satisfy both x greater than 0 and x greater than minus 1. That means if the number is greater than 0, it can satisfy x greater than negative 1 also. So their intersection is x greater than 0. After finding their intersections, we need to solve using one of the two ways. So solving for x can be made by simplifying simple laws of logarithmic functions. For this question, we can use the product rule of logarithmic functions. We know that logarithm of x times y to the base a can be expressed or expanded as logarithm of x to the base a plus logarithm of y to the base a. So using this, logarithm of x to the base 5 plus logarithm of x plus 1 to the base 5 can be write in one term as logarithm of x times x plus 1 to the base 5 using this product rule of logarithm. Thus, now we write or we simplify the expressions to the form of logarithm of x to the base a equal to logarithm of y to the base b, to the base a. Thus, this can be fulfilled if and only if x times x plus 1 is equal to 2. Thus, we can find this solution using any of the method you know from your algebraic exercise. So this is a quadratic function as we know. So this will be x squared plus x minus 2 equal to 0. Then you can use quadratic formula or completing square method or factorization method. Here I use factorization method. You can factorize this term as x minus 1 times x plus 2 equal to 0. So after this, you know that x minus 1 is equal to 0 or x plus 2 is equal to 0. That means the value of x is 1 or x equal to minus 2. But you have to know if it is in our domain or not. So we have to check the validity of the solutions after solving for the value of x. Here our domain is, as we done before, it is x greater than 0. So the value of x cannot be negative. It means so x equal to minus 2 cannot be a solution for this exercise, because if you substitute this minus 2, you got an undefined solution. So x equal to 1, which is in our domain, can be our valid solution and the only solution for these questions. Let's do the second question. The second question is logarithm of 2 to the base 2 plus logarithm of x plus 2 to the base 2 minus logarithm of 3x minus 5 to the base 2 equal to 3. So from the guidelines, the first step is to find its domains of each term. So the domains of each term can be found simply logarithm of x plus 2 to the base 2. These expressions have a domain of x plus 2 must be greater than 0. It means x must be greater than minus 2. The second is logarithm of 3x minus 5 to the base 2 have a domain of this expression must be greater than 0. It means x must be greater than 5 over 3. The second step is we need to find their intersections. Since x must satisfy, it should be greater than minus 2 and it should be greater than 5 over 3, their intersection will be x must be greater than 5 over 3. If it satisfies these conditions, it also satisfies x greater than minus 2. After that, we need to solve the value of x by using any logarithmic law. Here, we can use a logarithmic law of quotient rule. So from quotient rule, we know that logarithm of x over y to the base a can be expressed as logarithm of x minus a, logarithm of x to the base a minus logarithm of y to the base a. And from the product rule, it can be expressed as a sum of each individual terms. So here this can be expressed, but first we need to simplify logarithm of 2 to the base 2. It means have 1. So we can simplify this term to 1, and this 2 term can be expressed as a single term using quotient rule, as this x plus 2 over 3x minus 5 to the base 2 then equal to 3. Then if you this one, when it comes to the right side, it will be minus, so 3 minus 1 is 2, and logarithm of 2 x plus 2 over 3x minus 2 equal to 2. After that, changing this logarithmic function to exponential, you could get x plus 2 over 3x minus 5 equal to 2 the power of 2. This is the same as 2 the power of 2 is 4, then making crisscross, you will get 4 into 3x minus 5 equal to x plus 2. Then after solving this, you could get x equal to 2. The last step in the guidelines is, after solving for the value of x, check the validity of this value of x. So is x plus 2 in our domain? Yeah, because our domain is x must be greater than 5 over 3. We know that 2 is greater than 5 over 3. Thus, x equal to 2 can be the solutions, or it is valid solutions. The last question, but not the least one, is to find the value of x for a logarithmic equation, logarithm of x minus 5 plus logarithm of 10 minus x equal to logarithm of x minus 6 plus logarithm of x minus 1. So the first step is to find the domain of each term. Let's find them. For the first logarithm of x minus 5, the domain will be this x minus 5 should greater than 0. It means x greater than 5. For the second term, the logarithm of 10 minus x must satisfy 10 minus x must be greater than 0. It gives x must be less than 10. And the domain of logarithm of x minus 6 is, it will be this x minus 6 must be greater than 0. It means x must be greater than 6. And the last expression, logarithm of x minus 1, to be valid, it have a domain of x minus 1 greater than 0, or x must be greater than 1. The second step is finding the intersection of those terms. So their intersection of those 4 domains is simply x must be in between 6 and 10, because x greater than must be 5, greater than 6, and greater than 1. It means if a number is greater than 6, it could satisfy the other x greater than 1 and x greater than 5, and it should also satisfy x must be less than 10. So their intersection gives x must be in between 6 and 10. After finding the intersections of their domains, we need to solve the equation as we describe in our guidelines. So for solving for the value of x, we will use logarithmic rules. Here we can use logarithmic rule, which is product rule. So we can make these terms using product rule as logarithm of x minus 5 times x 10 minus x, which is equal to logarithm of x minus 6 times x minus 1 using product logarithmic rule. So for this expression to be satisfied, this x minus 5 times 10 minus x must be equal to x minus 6 times x minus 1. So we need to solve these expressions for solving x. Thus, x minus 5 times x 10 minus x, it gives minus x squared plus 15x minus 50, which is equal to x minus 6 times x minus 1 gives x squared minus 7x plus 6. Then rearranging these terms by making all terms going to the right side, which gives 2x squared minus 22x plus 56, which is equal to 0 if you divide both sides by 2, which gives x squared minus 11x plus 28 equal to 0. Then you can use any method you want for solving these quadratic expressions. Maybe you can use quadratic formula if it is simple for you, but here I use factorization method, and we can factor out this by finding two numbers which product are 28 and which the sum of the two numbers are minus 11, which are minus 4 and minus 7. So we can factor out these expressions as x minus 4 times x minus 7, which is equal to 0, which means x can be 4 or x equal to 7. Then the last thing we need to do after solving for the value of x is checking if this value of x are valid or not. So to check validity, we will check the domain from our step 2. In our step 2, we know that our domain is 6 to 10. The value of x must be in between this number. So 4 is not in between 4 and 6 and 10, so this is invalid solutions. The only valid solution is x equal to 7. So we need to select only the valid solution, and we know that the solution of these expressions is x equal to 7. So this is how we solve a logarithmic function.